Hello friends, this video on Redox reaction part 7 is brought to you by examfear.com. No more fear from exam. Let's talk about fractional oxidation number. We'll see some scenarios where the oxidation number comes out to be fractional. The question that comes to our mind is, why do we have fractional oxidation number when we know that the electrons are never shared or transferred in fraction? When there is a transfer of electron, it's about one electron, it is total transfer. It is never in fraction. It's never that 50% of the electron is transferred or 60% of the electron is transferred. It never happens like that. It's always the full transfer or sharing of electron, right? So why do we have fractional oxidation number? So fractional oxidation number comes when you talk about the average oxidation state. So average oxidation state sometimes gives you a fraction value. We'll take some example. For example, if you see in C3O2, if you apply and try to find the oxidation state of carbon, if you see oxygen will be -2, we'll apply the formula, the same principle, right? Free image of human face, right? So this is not a free element, this is not ions, this is not oxygen, so this is oxygen is here, so it will become -2. So this becomes Cr3O2 minus, right? So if you find this, let this be x, so this becomes 3x minus 2 into 2 is equal to 0, and you see x is nothing but 4/3. So you see the oxidation number of carbon is 4/3, which is a fraction. And why it is fraction? Let's investigate here. So if you see the structure of C3O2, it's something like this. So there are 3 carbon atoms. 2 of them has oxidation state of 2 plus 2, while the one in the center has oxidation state of 0. So if we find the average becomes 2 plus 2 plus 0 divided by 3, that is 4/3. Correct? Because oxidation state with the method which we applied gives the average oxidation state. Sometimes the oxidation state for a particular element in a or particular atom in a compound is not same. If there are 3 or 4 atoms, they may have different oxidation state, and that's why we get fractional oxidation number. One more example is B3O8. If you find the oxidation number, it comes out to be 16/3. And the way why it comes out to be 16/3, if you see the structure, these two bromine has oxidation state of +6, while the one in the center has +4. Similarly, Na2SO4O6 also, if you see the oxidation state of sulfur comes out to be 2.5, and if you draw the structure, you'll see that there are 2 sulfur with the oxidation state of 5, and there are 2 with the oxidation state of 0, so average comes out to be 2.5. And there are other examples of compounds which exhibit fractional oxidation state. They are Fe3O4, Mn3O4, P3O4. We'll take some examples now. We'll again find the oxidation state. Let's try to find the oxidation state of Ki3. Same formula will apply. Free image of human face, right? In this Ki3, can we apply free? No, it's not a free element. We can't apply the ions. Oxygen, there is no oxygen, there is no hydrogen, and there is no fluorine. We will apply the next principle, that is group 1 will have +1. There is a group 1, K, so this becomes +1, and let the iodine be X. Then with the sum principle, that the sum of all the oxidation state for this is 0, we'll get 1 for potassium and 3 for iodine is equal to 0. X comes out to be -1/3, and see this is fractional, right? And why is it fractional? Because the state of this Ki3 looks like this, I, and I. There are 3 I, and it's negative. So 2 of them will have 0 oxidation state, and 1 of them will have -1 oxidation state. So the overall oxidation state will be -1/3, the average. Correct? Similarly, S2S4O6, let's find the oxidation state. Let's apply same formula. F, we can't apply F. I, we can't apply I because not ion. O, yes, we can apply O. This becomes -2. H, yes, we can apply +1. We have this pending, so we'll be get X. So let's find it. 2 into +1 for hydrogen, plus 4x for sulfur, 6 into -2 for oxygen is equal to 0. If we solve this, we get X is equal to it becomes minus 12, minus 10, 10 by 4, that is 2.5. You see here also it's fractional, right? So if we draw the structure of H2S4O6, so if we draw the structure, it's H2S4, there are 4 sulfurs, right? And you have one OH here, one OH here, and then we have oxygen molecules like this. This has plus 5, this has 0, 0, and this has plus 5. And that's why the average is 2.5. Similarly for Fe3O4, let's apply the formulas. Free iron oxygen if we can have, we can apply this, become minus 2, this becomes X. So this becomes 3 into X for iron minus plus 4 into minus 2 for oxygen, this is 0. You get X is equal to 8 by 3. So how to see the structure? The structure will be FeO, Fe2O3, like this. In this case, FeO, it has plus 2 oxidation state. In this case, it has plus 3 oxidation state. So the average is 3 into 2, 6 plus 2, 8 divided by 3 because it has 2. It has 1. 3 into 2, 6 plus 2, 8 by 3. Okay. Next we have CS3CH2OH. Let's again try to find. We have the formula FiOHF, right? Free we can apply, iron we can't apply, oxygen yes we can. So let's put minus 2 here. Hydrogen we can, right? So plus 1, plus 1, plus 1. We have carbon remaining. So let's carbon be X. So you get carbon, you get 2X, plus hydrogen we have 3, plus 2, 5, plus 6, 6 into plus 1. Oxygen we have 1, 1 into minus 2 is equal to 0. You solve this, you get X to be minus 2, 4, 4 minus 4 by 2 minus 2. And that is correct because it is not fractional, right? So it is pretty good. Let's do for some more examples. CS3COH, again the same formula. Free image of human face, right? So this becomes free, we can't apply. Ion we can't apply for this case because non ion. O we can apply, so let's suppose minus 2, minus 2. H we can apply, plus 1, plus 1. C we can make it X. This becomes how many C? 2C, 2X. How many H? 4H plus 4 into plus 1 plus oxygen, 2 oxygen into minus 2 is equal to 0. You solve this, you get minus 4 plus 4 cancel, X is equal to 0. X is equal to 0 is not possible because when you say oxidation state of carbon is 0, it is not possible because oxidation state of only noble gas is 0. So what is the trick here? The trick is this one. You have this CH3 COH if you draw the diagram of this. So this carbon will have oxidation state of minus 2 and this guy will have plus 2. Correct? Because if you see all the hydrogen will have plus 1. So this overall becomes plus 1 and this is plus 2. OH will have a minus, right? This will have minus 2. So overall if you see this is how it will be distributed. This is plus 2, this is minus 2. So overall it will be 0. Correct. Let's take COBr2. Let's apply the same formula. F free we can't apply, ion we can't apply, oxygen there is no oxygen, hydrogen we can't apply, fluorine we can't apply. Right. Then we have a first group element. No, we don't have second group element. Then group 2, the 13 we can't apply. Let's take bromine as 1. So if we take bromine as minus 1, cobalt is X, you get X plus 2 into minus 1 is equal to 0, or you get X is equal to plus 2. That means for this guy, cobalt, the oxidation number is plus 2. Let's take ZnCO3. Here also let's apply this series. Free, no. Iron, no. Oxygen, yes, -2. Hydrogen, no. Fluorine, no. Right? Then we have zinc and carbon remaining. Now we have zinc and carbon. Zinc is group 12, so I can make it +2. Carbon is X. So let's put the formula: +2 for zinc, plus X for carbon, plus 3 into -2 for oxygen equal to 0. You solve this, you get X equal to 4. So carbon is equal to 4. So the oxidation state of zinc is +2, carbon is +4, and oxygen is -2 in this. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.